This is the last part of the notes for section 9.4 on vectors. These are the application problems. And in these applications, we're dealing with forces, but this is a very simplified view of forces. It really gets rather complex. Basically, a force is an energy, and you probably have heard of force is mass times acceleration. Since mass is in kilograms, acceleration is meters per second squared. Force has this units of kilogram meters per second squared. My critique of physicists is they don't like messy units, so then they create a whole new one, they honor somebody, and they call it a Newton. And so when we're working with these problems, one of the units to describe force is a Newton. Another unit to describe force is pound, and that's because weight, pounds, is actually the force due to gravity. So you're going to be given some information, and in this case, you're given a picture, and you're told that there are two forces acting at a point, right? And we're going to always make that point the origin. And one force has a magnitude of 40 newtons, and it's at a direction of 30 degrees. The other force has a strength of 60 newtons, and it's at a negative 45 degrees. I know I just went through showing when you write a vector for me, don't put the negative angle in there. The reason the negative angle is here, because it helps you understand better what's happening in this picture. And so when you're calculating these application problems, it's okay, because that's not your final answer. Right? It's all right here. So we have to find the direction vector. And the direction vector is found by adding those two vectors. And what we're going to get from that is the direction that these force. Just think of it as one person's pulling at F1, one person's pulling at F2. Where is that object, that point, going to go? And so we need a new direction vector telling us where it's going to go. And then we need to know what that force of that new vector. And so we have to find the magnitude after we add the two vectors. But in order to add them, we have to write them as a vector. So you first are going to write it in the polar form, then change it to a rectangular form so you could add them. So force 1, remember the magnitude it's told us is 40. So the vector for force 1, now you see these bolded, that's also another way to write a vector. It's hard to write it on a piece of paper, it's bold, so that's why I usually put the little arrow above. Okay, so that's 40 times I times the cosine of 30 degrees, because this is vector 1, plus j times the sine of 30 degrees. So you go ahead and I'm going to stop this for a minute. You go ahead and write what force 1 is going to be. What I meant to say was vector F1. Now I did it in exact values right here. I will end up using decimal approximations, but right now I'm doing it exact. Right now we're going to do it for force vector 2, F2. That magnitude is 60. So I do expect you to write this out. This is how I know that you know what's going on. Now again, stop the video, go ahead and find what the vector for F2. So again, I found F2 as a vector using exact values because it's easier to see as I add them what I need to do. And you're literally adding F1 and F2, just like you're used to adding like terms. So F1 was 20 times the square root of the I. plus 20j. F2 is 30 square root of 2I minus 30 square root of 2j, because F2 is going into the fourth quadrant, so the y component better be negative. So then you have to combine like terms. I could add the i's and I could add the j's. But note, I really can't add them because I can't add square roots that are different. I could write them together, but I can't come up with one number. Because square root of 3 and square root of 2 don't add. But you could find decimal approximations for these, and you could check the math. So now you could find the magnitude, because now we have, this is the resulting vector. This is where F1 plus F2 is going to go. And if I look at the coordinates, x is 77.1, y is negative 22.4, it is going to be somewhere here. Which I hope you figured that that's probably where it's going to go, because F2 is a stronger force, so it's pulling more down than F1 could pull up. So stop the video, find the magnitude. Okay, so I got 80.3 newtons, and it's newtons because that was the unit that we started with. And so we figured out where this vector, this force is going, what direction it's going in, and how strong it is. Now, this hopefully makes some sense because it is combining the x-coordinate of force 1 plus the x-coordinate of force 2. They are adding together because they're both going to the right. And so that's why it's going to be a stronger force going to the right. Even though the y component is canceling out a little bit, because force 1, the y component is going up, and force 2, the y component is going down. But when they combine, you're still going to get a strong force going to the right. Okay, the next one is these ramp problems. And generally, they don't draw a picture for you. So you're going to have to draw a picture. And this scenario, I have a boat, right? And you're told that the magnitude of 700 pounds of force is required to hold a boat and its trailer in place on a ramp, and that the incline of that ramp is 10 degrees. When they say 10 degrees horizontal, that just means you have the ground, and then the ramp is 10 degrees off of the ground. So then the question is, what's the combined weight of the boat and the trailer? Now, like I said before, weight is the force due to gravity. And this weight, the force of weight is always perpendicular to the ground. And so at a point, we could think of it being perpendicular. Now, there are three forces we have to think about. The weight of the boat and the trailer, okay, that's the force due to gravity. The force that the object, that boat and the trailer, are pushing against the ramp. There's always a force pushing against things. This isn't the same as the weight. And this force is perpendicular to the ramp. And then there's the force that's keeping the boat from sliding backwards. And so this is a force that's parallel to the ramp. And friction has a role in this force. And like I said before, we're looking at a very simple picture, right? I've simplified the physics here. All right, so I drew a picture for you. We have our ramp that's at 10 degrees incline here. And we have a boat on the trailer. And we're looking for, as the problem said, we're looking for, what's the combined weight? Sorry about that. Looking for the combined weight of the boat and the trailer. We're told that the force to keep it from sliding is 700 pounds. Okay, so we're told this red force, right? That's what we're told. And then there's also the force of the boat itself pushing against the ramp. I call that the force of the object. The ramp is 10 degrees. This triangle that's made between the force of weight, the force of the object, and this like keeping from sliding force. This little angle, I squeeze it up here. That little one up here is also going to be 10 degrees. Now this sliding force is going to be perpendicular to that object force. And so we have a right triangle, which I drew over here. So we were told the force to keep it from sliding was 700 newtons. 700 pounds. So we were told this in the problem. We are looking for the combined weight of the boat and the trailer. So we have a right triangle. This is what we're doing very first week of class. We're just solving for another side of the triangle. In this case, the side we're solving for is the weight of both the trailer and the boat. So you just pick the trig function you see. You have options here because we're just solving a right triangle. So what I see is the sine of 10 degrees equals 700 over the force that I'm looking for. So I could solve for the force that I'm looking for. And you should get an answer. The combined weight of both the trailer and the boat is 4,031.1 pounds. Now be careful. Every single object against the ramp problem isn't always solving for the same side of the triangle. You're not always given the same information. So make sure you draw your triangle and pay attention.